Hey everybody, welcome back to Young Engineers of Today. How was everybody's weekend? Good, bad, and different? Good, good. I'm glad to hear that you guys had pretty good weekends. Mine was all right. I mostly just spent it working, but I made some money, so that's always nice. Um, but yeah, it was just working. That's all it was. Nothing terribly exciting. Though I did get to go out and do karaoke on Friday night, which was pretty fun. But yeah, today is going to be the final day of Godot. Some of you may be rejoicing, some of you may be going, oh. Regardless, it is going to be the last day we're going to be messing around with Godot. It's actually the second to last class that we're going to have for the semester. So Wednesday is our last class for the summer. Wednesday, you'll see what we're going to go over. It's a little bit different. We basically just talk about, jobs and stuff like that. Um, if you've been in my class before, you've probably heard me do the whole spiel about it. Um, I apologize, there's going to be another one of those. Anyway, that's what we're going to spend Wednesday doing. But yeah, again, for today is just going to be finishing up stuff with Godot. Now, what exactly does that involve? Well, I'm glad you asked. And that is an excellent question. Today, we're pretty much just going to spend um, customizing our Pong projects. So if you want to add anything to it, um, that's what we're going to spend today doing. It's going to be more freeform than usual because there isn't really a set lesson. I might go over a couple of things just to give you guys some ideas and stuff like that. But, if you have something you really want to add to it, um, I'll definitely help you implement that as well. And, more of the traditional style so everybody else can see how it's done. So that usually means we'll have time to implement a few things. Maybe not everything that you guys want to do, but that's the wonderful thing about learning is you can spend time Googling it and everything like that and trying to figure out your particular sort of flavor to this game. But yeah, it's again, this is entirely free form. So anybody right now off the top of your heads, do you have anything you want to add to the game? Um, Anything you want to change about it? Anything like that? A scoreboard and a way so that the paddles go a little faster every time the ball goes faster. Yeah, that's definitely doable. We could spend some time figuring out how to implement that. Anything else? Well, in the meantime, let's start implementing the scoreboard. Um, the, Perhaps the best way to do this would be to put some labels onto our view screen, just directly on there. And so we can get that implemented so that we can at least see a score and maybe reset the game every time the score hits a certain amount, like first to 5 or something like that. And then the way that making the paddles go faster, that'll definitely be doable. We'll go into that as well. So I guess let's implement a way to make the paddles go a little bit faster, just as our first thing, since that is super, super simple. So let's see here. I'm going to enter into my script. Here we are. We've got, yes, hi cat. We've got our lovely script here that we've been dealing with. Now, based on everything that we've got here, what do we use right now in order to make the pads go a certain speed? Yeah, exactly. Now, is there a specific thing in there that we use to determine the pad speed? I don't know if you can hear my cat, but he really wants to go outside right now. Well, delta is actually the thing that's pulled from process. Remember, that's the thing that's how long it's been since the last time delta was called. Let me rephrase that. What do we use in order to determine how fast a paddle will move in a given second? Almost there. Go in between those. Yeah, yeah, exactly. Pad speed is the variable that we use right now in order to tell the computer how fast to move those paddles. The plus equals does the actual changing of the position, and then the delta is a multiplier which moves them a given fraction of pad speed depending upon how long it's been since the last time process was called. But pad speed is actually the variable that we use which tells our program how fast those paddles are going to move. Now, what we could do, and what we're eventually going to do, is basically just sort of add a little multiplier so that the paddles move a little bit faster each time somebody scores. What's preventing us from just doing that right now? What is it about pad speed that prevents us from just doing some math to it as it stands right now? And how can we fix that? Go back to where pad speed was declared at the top and see if there's anything unusual about it compared to the other variables. Yeah, exactly. It's a constant. A constant is something that we hard code into the script and does not allow us to change it using math in the script while it's running. So it's a value that we cannot change while the program is running. So that's basically right now it's preventing us from being able to change pad speed in our script. Doing the same thing that we do with ball speed. However, there's a really easy fix, and what might that be? Exactly. Making it a variable. That's all we have to do. So we're going to go up here. I have it on line 13. You might have it, well, you might have it on line 13 too, since I did the whole put it into the chat box and everything. So I'm going to go up here and I'm going to change constant to var, short for variable. So now pad speed is a variable. Now we can change pad speed down here with all kinds of math wizardry, and it can update as it needs to. So I'll give you guys a second to locate where the scoring happens. I just highlighted it. But, but remember, the scoring happens in an if statement, right? It's asking us where the ball is, or sorry, not the scoring, when it bounces off a paddle. It's an if statement. It's asking us where the ball is, if it's touching one of the rectangles, and if it is basically heading towards that rectangle. And the rectangle, when I say rectangle, I mean the rectangle that surrounds one of these paddles. So here's what we're going to do. In that, you'll notice that there's one line that says ball speed times equals 1.1. So that line right there makes the ball speed up. We're going to do a similar thing for paddle speed. So we're going to say pad speed times equals, and we'll say 1.05. So it won't speed up quite as much as the ball will. However, the paddles will speed up. so they will move faster. And by changing this pad speed to a variable and adding in this little multiplier here, we can actually test this out. See how fast the paddle moves. And it's going to be a much less dramatic change than it is with the ball. But the more we use it, the more we can recognize the fact that, yes, the paddle is actually increasing in speed. You can make the multiplier larger if you want the paddle to move faster every time it hits the ball. So you can make the multiplier 1.1 just like the ball. You can make it even higher if you wanted to be a masochist. You can make pad speed times equals 2. And so now let's actually take a look at that, because that would be ridiculous. Let's make pad speed times equals 2.0. So now we can see how fast the paddle is moving. We'll let it bounce off the ball, and now it's just moving super fast. We'll let it bounce off the ball one more time, and it will suddenly become difficult to control the paddle to get it to go exactly where we want it to. So let's hit it one more time, and now they're just moving absurdly fast. See, I actually overshot and moved it past the ball at that point. Now, as you're watching me do this, you might notice something that you'd want to fix, other than obviously the paddle speed. Now let's go ahead and do this, and it bounces down like it always does. Now what's funky about this? Yes, hi. Well, I'm really interrupting Cat right now. I'll just go ahead and say that, you know, it's kind of strange that the ball's heading in the same direction. It has the exact same vector even after it resets. We'll worry about that in a moment. For now, we've got the paddles moving faster. Let's go ahead and implement a scoreboard. So, first off, we should probably find out where we want to display the scores. We want it to be in a sort of out of the way spot, or one that's not really going to be a huge issue if, you know, the ball moves through it. So having said that, I'm going to put my little scores up here. We're going to have our left score on this side and our right score on this side. And I made a stick man. Boop, 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 boop. I am the best artist. Anyway, so that's my plan right now, is I'm going to make this area right here devoted to the score for the left paddle, and this area right here devoted to the score for the right paddle. Now, what is a really easy way to display text and numbers on the screen? This is something we used in a previous project, so it might be something that's not exactly fresh in your memory, but it's actually a very, very straightforward sort of implementation. Exactly. It's a label. That's all we're going to need. So what I'm going to do is I'm going to make two labels that are the children of Node 2D. So label, regular label, and another label. Oh, nope, not a rich text label. Regular label. There we go. So now I've got label and label 2. I'm going to go ahead and rename these. We're going to call them left score and right score. And we're going to move them to appropriate positions. See, now I've got left score and right score on the appropriate sides of the center line. So now we can see that there are left and right scores. Let's go ahead and start it up again. Nothing looks different. But that's okay. That's not really surprising to you guys, right? Like, we have to put stuff into the label in order for it to be displayed on the screen. Like, that's pretty much, you know, game design 101 or game programming 101. It's not, there isn't going to be any information in there unless we tell it what information goes in there. So let's go ahead and stick these to these spots by locking them in place so they don't get moved around. Actually, I am going to move this one down a little bit. There we go. Compare it to this side. That looks good. Now we'll click the lock, and that will keep these in place so we don't accidentally move them later on, which is excellent. We would like that. Yes, hi kitty. Gonna yell at me some more? He loves to go outside during storms, and he thinks that when storms are brewing, it's his time to be let outside, when in reality, unfortunately, he's never actually allowed to go outside. That's not my decision, that's the leasing office. And I'd like to keep my apartment. So anyway, here we are in our script yet again. Here we're going to put in some information in order to put it into our labels. So I'm going to say, realistically, we probably want a couple of variables holding the scores, right? That would make things a little bit easier. So we're going to say VAR left score equals 0 and VAR right score equals 0. Variable left score and variable right score. And we're setting them to 0 immediately as soon as the game starts. Now, we need to update that score every time one player or the other scores, right? Because otherwise the score is going to remain 0, and that's not going to be terribly exciting. You might as well just, I guess, give participation medals to everybody who plays your Pong game. So we're going to have a score increase each time somebody scores a point, you know, so that there's some competition and everybody can get all, you know, serious about it. So now we've got, where again is the scoring if statement in this? You can give me like line numbers if you would rather not type it all out. .37. So if left rectangle has point ball position and direction.x is greater than 0, or if right rect has point ball position and direction.x is greater than 0. Well, that is actually asking whether or not we're hitting one of the rectangles, because you see the left rectangle, it's asking if it has the ball, like a point in the ball. Likewise with the right rectangle, it's asking if we have a point in the ball. So that's asking whether or not we're colliding with our paddles. Yeah, That was a good guess, though. Line 44, if ball position.x is less than 0 or ball position.x is greater than screen size.x. That's the one. We're asking if the ball position is, if the position of the x position of the ball is less than 0 or greater than the screen size. So that's exactly the one we want. Now, all this is asking is if a scoring event is happening. Now we need to differentiate between whether the left paddle or the right paddle has scored. Thankfully, we can just do that with a couple of if statements nested inside of this if statement. Generally, it's kind of poor form to nest if statements too much, but I'm feeling a bit lazy right now, and this helps keep the structure of our program intact. So I'm just going to go ahead and nest these if statements in here. So all I'm going to ask is, well, what am I going to ask? Right now we're asking if the ball position is less than 0 or greater than screen size on the x-axis. Now we need to differentiate between whether or not the right or the left paddle has scored and increase their score appropriately. Well, I might just ask if ball position.x is less than 0 or if ball position.x is greater than screen size.x. That's all. So if ball position.x is less than 0, that means that the ball hit this side of the screen, which means that this paddle should score. So it went off the left side of the screen, which means that the right paddle should score. So we're going to increase right's score by 1. And then the exact opposite is happening the other way. So if it's greater than the screen size, this means that the left paddle is scored because it passed the right paddle. So we're going to say left score plus equals 1. So now we've got two if statements embedded into our original if statement. And these will appropriately update the left and right score. Now, I'm just going to go ahead and run it, but there is still one more thing missing. There's still nothing up there. What am I missing? I'll even let this fly by so we can have the score increase. Yep, still not showing. What exactly am I missing? Yeah, I gotta update the text in my label, right? Well, let's go ahead and do that in process. If we do that in process, we can ensure that no matter when a scoring event happens, whether it's right at the beginning of the game or 30 minutes in, or if you score twice in a second somehow or whatever, it will always be displaying the correct score. So we're going to put that in process. We're going to get each node. So now we've got left score and right score nodes. Now, since these are labels, they have some built-in functions to them. One of those built-in functions is SetText. So for both of these, it's get node, either left or right score, .setText. That's what we're using. And we're going to set that text to left score and right score. So far, so good, right? There's one more thing we have to do. If we were to run this right now, it would yell at us. As you can see, it just immediately quit out. It said invalid type in function SetText in base label. Cannot convert argument 1 from integer to string. What? What does that mean? Well, I'll tell you what that means. Remember how variables will have types? They can either hold whole numbers or decimal numbers or letters or directions or whatever, right? But they can only hold that kind of thing. You can't just sort of switch them around willy-nilly, especially with strongly typed languages like C or Java or something like that. If you declare a variable, you have to declare the type of variable when you create it. And if you declare a variable of a certain type, like an integer, it will only be able to ever hold integers always and forever. Amen. Like, that will never change. So even though this isn't strongly typed, this is a variable. In something like this, we just declare a variable, and then it kind of figures out what kind of variable it is by the stuff we fill it with. So we said variable right score, and so far it's like, all right, I'm with you, I don't know what's going to hold, but I'm with you, and we go equal to 0. And it goes, oh, okay, so this is going to hold whole numbers. All right, fine. Like, you know, how we did with pad speed. It's like, oh, variable, all right, good, so far so good, equals 150. Yep, gonna hold whole numbers. All right, like variable direction. So far so good. Equals vector 2. Oh, this is a vector 2 variable. It's going to be holding a two-dimensional vector in it. All right, I'm with you. Everything's cool. So that's kind of how variables work in Godot script, in Python, in I believe in JavaScript as well. So the caveat still stands that if we set a variable up to be a certain type, which we've done here by setting it equal to 0, we've set it up to be type integer, we can't make it a string all of a sudden out of like magic, you know? What we can do, and that's why this freaks out, because SetText needs a string, right? It needs a collection of letters or characters or whatever in order to display it at the screen. And what we've given is we've given it a raw number, and it doesn't know how to translate that into a string. However, the nice, lovely people, John, I forget their names. There are two guys who basically made Godot, which is actually pretty incredible considering they've made a game engine. Ariel Menzer and John something or other, I believe. They have implemented a two-string function. Well, what is that? Well, it will take a raw number or a raw vector or whatever, and it goes through basically a function like what we've got here with ready, or you know, with getNode, or SetText or whatever. It's a specialized function that basically takes in another data type and figures out what the equivalent string is. With that equivalent string, you can then print it to the screen with SetText. Now, how do we summon this function? How do we get it so that we can convert this into a string? I'll tell you, it's really easy. It's just str, and then put whatever you want to convert into a string inside of the parentheses. So as you can see, I've got two sets of parentheses right now. I've got a set of parentheses for my string converter, but that is wrapped inside of my SetText function. And then inside of that is our variable. So what exactly is going on here? Well, we're working from the inside out. We say, okay, it's going to set text, and it's like, all right, fine. Or we're working from the outside in, I guess, if you want to be correct. So we're working from the outside in. We start out, we get like a call to set something to text. It goes, okay, fine. What am I going to set to text? It looks inside here. It goes, oh, there's another function. So let's take a look at string. And then it's going to go, okay, so I'm going to call string. What do I need to send to string? Well, we put variable in there, right? So it's going to send variable to string. and then string's going to spit out a string, which is basically just going to replace all of this stuff inside of here, and then that's what text is going to use. So let's go ahead and see how this is going to work out. Hey, look at that. I got zeros up here. Now, if I were to let the left player score very slowly, look at that, 1. Now let's let the right player score. Bounce, bounce, 1. It's now 1-1. We have a tie game. But it looks a little wonky up here, doesn't it? Like, we've got this one so far away from the center line, and this one is so close to the center line. This is not really my ideal situation. Thankfully, there's a really easy fix for that. That's the nice thing about this. There are really easy fixes for a lot of things. You just have to know the right buttons to press. So let me go ahead and close this out. Here is our code to print the score to the screen, just in case you need it. So, how many of you at this point would consider yourselves pretty familiar with text editors like Word or the OpenOffice equivalent, or the Macintosh equivalent or something like that? One hand. All right. 2 hands. Okay. Hey, you guys have probably written a fair few essays at this point. And if they've ever asked you to type them up, chances are you've used one of those programs. Now, have you ever had to mess with text alignments? Show of hands, I guess. Okay, 1 hand. Maybe messed a little bit with text alignment. All right, well, for those of you who aren't familiar, in modern editors, also in English-speaking language, or most Germanic and Latin-based languages, we read from left to right, right? We read from left to right and top to bottom. Now that's different from a lot of Asian languages, but as it stands for us, we read from left to right and top to bottom. So the natural state for a text editor is to take all of your text and then just cram it all against the left margin. It's called left alignment. Now, this means that in our 2 labels, they're both left aligned. We have a number in each of them, and it slams them to the left, which is fine for this one. However, on this one, it makes it go further away. So our really easy fix is just to select our left score label, and on the inspector, there is an align option. Change that to right. That's seriously it. Let's go ahead and run it again. Look at how much better that looks. Now, they're a little bit off, but that's just because I'm terrible at aligning the actual boxes themselves. But there you go. Now we've got scores hanging out on the edge of either center line. Or on either edge of the center line. That's what I meant to say. Of course. So boom, done. It took us half an hour, and I spent the whole time explaining to you guys how to implement this stuff. If you knew, like if you were sitting here and you're like, yeah, okay, I want to implement a score, you could do it in less than 5 minutes. You could change the speeds and implement the scores in maybe like a minute and a half. Like, bam. This is what this is all about. This is about rapid, sort of prototyping. Well, not really prototyping, actually. Rapid development would be a more appropriate thing to say, of games. And that's part of the reason why I enjoy it so much. But yeah, that was, after all was said and done, pretty easy, right? All the concepts are stuff that you guys are already familiar with. Now let's see here. Let's go ahead and okay, there's a couple of different directions we can go into right now. We can have the game reset as soon as a certain score is hit. So basically the scores get reset to 0. The ball speed goes back to its base value, so do the paddle speeds, and then everything starts over again. Or we could look into changing the text, or we could do something totally random. The text of the scores, I should say. So what do you guys think? A win label. All right. That's definitely doable. All right, let's see here. So we'll put in another label. As before, no surprises here. And we're going to call this game End. And I'm going to drag game end down here to the middle. Increase its size, even though that's largely unnecessary given the size of the text already. We'll make it center aligned. And we'll change the font color to a nice, atrocious red. So that way, you know, we'll never, you know, miss that there is a win condition right there. Now this is just sort of floating there. Whoops, let's go ahead and unlock it real quick and move it up a little bit. There. This is just sort of floating there. And it's visible. If there was actually text inside of our, you know, label, we could say like blah blah test and hit enter. If we were to play our game, now it's just kind of floating there in the way, and that's sort of annoying. So let's go ahead, and what we'll do is we'll make it invisible until it's time to report a winner. And the way you do that over here in the scene view, as you can see, there are little stylized eyeballs next to each of these. I'm going to click the eyeball next to game end, and it'll turn into a closed eyeball, and now it's invisible. If we're to run it, look at that. Nothing there. Nothing. So, let's implement our win condition in the script, right? What do we want the score to go to? 3 or 5? Maybe 7. 3, 5, or 7? 7? We're going for the long game. Alright, let's implement it at the bottom beneath all of our other if statements, but before where we update the position of everything. Oh, wait, no. A little bit too early. Before we update the position of the ball. So we're going to say if, of course, if left score is greater than 6 or right score is greater than 6, because remember, we're going to 7, so we want to make sure that the game ends at 7. And the easiest way to do that is to say if the left score or the right score is greater than 6. First, what we're going to do is we're going to get node game end dot set visible. Wait. I guess set hidden, and then set that to false. So now, you know, I'll test this with just a score of 1. We'll let that one score, and we'll see if it pops up. Blah, blah, test. It's an easy way to test things out. So, set hidden is the function that we want in order to make sure that our game end label appears. Now what we're going to say, we're going to ask if the left or the right person won. So we're going to say if left score is greater than 6, you'll notice I changed the second if statement to ELIF. That's short for else if. So we're asking if the left score is greater than 6, else if it's not, or rather I should say else if right score is greater than 6. We're going to get node game end, and we're going to set the text to player 1 wins with no D, because I can't type, I swear. And or otherwise, we're going to say get node game end and set text to player 2 wins. So now, again, let's set this back down to the first score to 1, and let's see how this looks. So as soon as the left player gets 1 point, which is about to happen in a moment, we should see player 1 wins pop up on the screen. It didn't happen. Ah, that's why. Because I forgot to reset those. And player 1 wins. Hey-oh. So we'll set these back to greater than 6. So we have our normal scoring game. Now there's probably a couple other things we could do. What I'm going to do is I'm going to reset the scores. I'm going to reset the speeds. I'm going to place the ball back in the center. So we're going to say ball position equals screen size times 0.5. Direction equals vector 2, -1, 0. Ball speed equals 80, and pad speed equals, what was it originally? 150. Now I know I just added like 3 more lines there, but this is, this is stuff that you guys should be pretty familiar with too. We've reset these values back to what they were originally up here. So it's like everything's sort of reset. And then we'll say left score equals 0, right score equals 0, and then we can just play the game again as per normal. In fact, that's exactly what's going to happen, is the game is going to restart again as per normal. Now what I am going to do up here, when the scoring happens, I'm going to make it so that the ball starts heading back towards the middle. There. So now we should see player 1's score, and then it will go back to the middle and start heading directly towards player 1 again. Boom, look at that. And it's going to go up that way. We're going to hit it with the left paddle, or both paddles a little bit too, in order to speed it up so that we can get a high scoring game pretty quickly. and we can see the difference. Make this go faster, faster, faster. All right, we're speeding the ball up. We're speeding the ball up. It's looking promising so far. All right. There we go. This should be fast enough. And we'll just move this out of the way. And in an upset win, player 2 is going to win. Or in an upset, I should say. Player 2 is going to win. 5, 6, and 7. And as you can see, the ball is moving slowly again. The paddles have returned to the normal speed. Only problem is player 2 wins is now just kind of stuck on the screen. So there's one more thing we need to do. We need to make it so that the text stays on for a little while, and then the text becomes invisible again. So let's see if we've got a pause or a wait or something of the sort. I'm going to look that up real quick, because I'm not sure if there's a built-in like wait function or pause function. Let's see here, let's see here. This is the only problem with something named Godot and asking Google if there's any sort of pause or wait function, because it's based on Samuel Beckett's play Waiting for Godot. So if you type in waiting in Godot or wait function in Godot, well, you only get the play listed. Well, we can do a little bit of script wizardry here. I'm going to create a new script. I'm going to call it game end.gd. All one word, game end.gd. And what we're going to do is we're going to set the process on it. This is going to be a little bit wonky, but if get hidden. Oh, don't worry, I'll explain this in a moment. I just want to test this out. And before we do that, let's just do our real quick test again. Well, that ain't working. All right, let's see what we got here. You can always debug with, printing to console. So we'll see if this actually is entering the proper things that we need. It's not. See, there you go. Interesting. There is no actual... Oh, is it is? There we go. That should do it. Or not. Curious. It doesn't seem to want to get the hidden state. Whoops. I forgot that closing that actually closes down Godot. That is also an alternative output, by the way. If you ever want to see if there's something that Godot isn't telling you is wrong, and it's telling you that something's wrong, but it's not telling you what's wrong, you can always check this output over here, because there's going to be a lot more information on that. Didn't actually save our game end. There we go. Attach it. Save scene. Yeah, there we go. Okay. Now it's doing what it's supposed to, which is being wonky. There we go. Now it resets properly. So I attached a script to our game end, which will automatically hide our little win message, win label, after a certain period of time. So what it does is it prints the state of whether or not it's hidden to the little console debugger down here. and it constantly checks to see whether or not it's actually hidden. Once it's hidden, then it will print whether or not it's hidden, and it will also say in get hidden, and it will add a small amount to the awake time. It starts at 0. It will add delta to the awake time. Once awake time has exceeded 1.5, which means that how long has it been awake? Just as a guess. It's actually, never mind, it's listed in the code. 1.5 seconds. That's why I typed that. Then it will print the hidden state. It will say in get hidden. It will say awake time greater than 1.5 seconds. It will set it to hidden again, reset awake time, and then we'll start the process all over again. So the label will stay on the screen for exactly a second and a half, displaying the winner before, once everything resets. This ensures that it goes away after we win, and all that stuff, and we have enough time to see who the winner is. Yeah, definitely. Let me go ahead and post the entire code to the chat box. It's going to, if left rectangle has point ball position direction X, or right. And then here's part 2. And here is part 3. It's now large enough that we have 3 parts to it. In fact, I can actually put this all in a paste bin as well and post that so that you guys can actually access it more easily. Because if that's going to just keep doing that, then there we go. That's a better and neater way to get the Pong code, is to go to that paste bin, because it will actually keep all of the formatting and everything like that. Paste bin is a wonderful, wonderful thing. And then we'll put the this on. I have to solve a CAPTCHA. Okay, I'm not a robot. This will be the code that we'd put on the game end. I'm going to skip the poll questions for today just because it's already past 8 o'clock. If you guys have any questions about anything that we've done so far, you're more than welcome to. In the meantime, I'm going to add a particle effect to the ball. If you want to hang around for a couple more minutes and see how I do that, you're more than welcome to. Otherwise, you can head out, have a wonderful couple of days. We'll see you on Wednesday for the final class of the semester. So, yeah, have a good one. No problem, John. Have a great day. Well, have a great couple of days.